Objective is to correctly identify the periodic trend of valence electrons and ion formation. So let's start with valence electrons. They are the electrons found in the outer energy level of an atom. So it's these valence electrons that are involved in bonding with other elements. And if you look on the periodic table, the group number tells you the number of valence electrons. So group 1A has 1 valence, group 2A has 2 valence, group 3A has 3 valence, and so forth. Elements in the same group or family are going to behave similarly because they have the same number of valence electrons. And so this is showing you the pattern of how many valence electrons there are in each of the families on the periodic table. Notice the one exception, helium, is in group 8, the noble gases, but it doesn't have 8 valence, it only has 2. To show valence electrons, we use something called electron dot structures or Lewis dot structures. Write the symbol surrounded by valence electrons. You do not have to show inner energy level electrons. So, for example, hydrogen is going to has only 1 valence electron, and so we're going to just place 1 dot next to it. It could be on the right, at the top, on the left, or at the bottom. Doesn't matter. Helium has 2 valence electrons, so I tend to start from the top and work my way around clockwise. So we're going to put my first valence electron here, and then the second valence electron would go here. Technically, most people would say that the 2 valence electrons are paired together, but we're not going to worry about that here. Oxygen has 6 valence electrons, so starting at the top, we're going to do single, 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 single. That's 1, 2, 3, 4, and then pair them, 5, 6. And then iodine has 7 valence electrons, so it's going to go 1, 2, 3, 4, 5, 6, and then I'm going to put the 7th one on the left side. So notice it's 3 pairs and 1 single. On oxygen it's 2 pairs and 2 singles. So it's important just to note that the number of dots you see around are representing the number of valence electrons. Now pause the video, take a moment, and draw the Lewis dot structures for each of the following elements, and then unpause the video to see the answers. Here are the answers to your Lewis dot structures. Chlorine should have 7 dots because it has 7 valence. Rubidium has 1 valence, 1 dot. Magnesium, 2 valence. Aluminum, 3 valence. Krypton, 8 valence. And phosphorus has 5 valence. Now, without looking at the periodic table, can you tell the group number each of these elements would be found in? Sure you can. All you have to do is look at the number of valence, and that equals the group number on the periodic table. Silicon has 1, 2, 3, 4 valence, and germanium has 1, 2, 3, 4 valence. Remember, valence are the electrons on the outermost energy level, so both of these are going to be in group 4 on the periodic table. These have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All of these have 7 valence, which means they're in group 7 on the periodic table. So how can I identify the group of this unknown element? I simply will count the valence, 1, 2, 3, 4, 5, and so this element would be found in group number 5 on the periodic table. Ions are going to be when neutral atoms gain or lose electrons and they become charged atoms called ions. The oxidation number is going to be that number with a charge, positive or negative, and it tells you the charge of the most stable ion for each element. The oxidation numbers follow a pattern on the periodic table. So remember our group numbers again, 1A, 2A, 3A, all the way to 8A. And so 1A are going to have 1 valence that they'll tend to lose and become a positive 1. 2 valence, lose 2, become plus 2. 3 valence, lose 3, become plus 3. 4 valence can go either way. They're either going to lose 4 or they could gain 4 and become a negative 4. If we have 5 valence, now we're going to start gaining electrons. 5 is going to gain 3, and that'll have a negative 3 charge. 6 will gain 2 and become a negative 2 charge. 7 will gain 1 and become negative 1, and 8 is going to have 0 because 8 is the maximum number of valence that we actually want to achieve. Atoms form positive ions when they lose electrons. These are called cations. Atoms form negative ions when they gain electrons, and these are called anions. Anions and cations have opposite charges, and opposite charges attract each other. So let's illustrate the process of an oxygen atom becoming an anion that has a -2 charge. Here is a neutral oxygen atom. It has 2, 4, 5, 6 valence electrons. To have 8 valence is called an octet, which is what all atoms want to have. So I want to gain 2 more electrons. And so over here, I'm showing 2 electrons that make their way to oxygen, and then they pair up with these singles. And now we have 2, 4, 6, 8 electrons, which is going to carry a -2 charge. So we added 2 or gained 2 electrons, and so since we gained 2 negatives, we have an overall -2. This is called the oxide anion. Anion because it's negatively charged. Illustrate the process of a sodium atom becoming a cation with a +1 charge. So here's a neutral sodium atom which has 1 valence electron. To become a sodium cation with a +1 charge, we have to get rid of that 1 valence, and when we lose that electron, then we get a positive charge because we've lost a negative electron, and so we are left with more protons than we have electrons, so it's got a positive overall charge. So as you kind of heard me mention, the goal in forming chemical bonds is that every element wants to be like a noble gas. In order to do this, they follow what's called the octet rule to achieve a noble gas configuration. It just means that they're trying to fill up their outer level of electrons. Hydrogen is special. It only has 1 valence electron, and so it's trying to be like helium, which has 2 electrons in its outer energy level. All other elements want to have 8 valence electrons in their outer energy level. When an atom becomes like a noble gas, it's happy and it's stable. So atoms with 1, 2, or 3 valence electrons are going to lose those electrons and become cations. So group 1 has 1 valence. They're going to become +1. Group 2 has 2 valence. They will become +2. Group 3 has 3 valence. They will become +3. They become +1, +2, and +3 by losing their valence. Okay, group 4 can be either +4 or -4. Now when we get to group 5, we're going to start gaining electrons. Atoms with 5, 6, and 7 valence electrons gain electrons and become anions. So group 5 is going to gain 3. Remember, the goal is to have 8, right? So we're going to gain 3 and have a -3 charge. Group 6 is going to have a -2 charge after they gain 2. The halogens are going to gain 1 and have a -1 charge. And the noble gases don't have to gain or lose anything because they already have the octet.